Good evening, ladies and gentlemen. We warmly welcome you all to the Green Talk conducted by the Green Building Council of Sri Lanka for the month of August. As the Green Building Council of Sri Lanka, we always look forward to improve and promote the built environment with sustainable practices with the vision to transform Sri Lanka's construction industry with green building practices to fully adopt sustainability as the means by which our environment flourishes, economy prospers, and society grows, ensuring the future well-being of our motherland. So, our monthly green talk on different topics will surely add something new to your knowledge. And also, profession like you are truly valuable to organization like us in promoting environmental sustainability in Sri Lanka. So then, now uh, let's move on our today green talk. Today's green talk topic is green hydrogen economy for next zero future. And the lecture will be conducted by Mr. Nimal Perera. Please give me a few minutes to introduce him. Mr. Nimal Perera is a chartered environmental professional in Sri Lanka, and he currently works as a national expert consultant in the field of energy, environment, climate change, and sustainable development. Mr. Perera is the president of the SCP Forum Sri Lanka, member of the Board of Trustees to the Asia Pacific Roundtable on Sustainable Consumption and Production, chairperson to the Consumer Consultative Committee to the Public Utilities Commission of Sri Lanka, and co-chairman of the Sri Lanka Energy Managers Association Green Hydrogen Working Group. And also, Mr. Nimal Perera completed his bachelor's degree from University of Colombo in 1983 and later has earned postgraduate qualification in industrial engineering, business and financial administration, pollution control engineering, industrial waste management and efficient energy use in industry from local and overseas universities and institutions. As well as Mr. Perera is a member of the SLABG as an expert team, and some of his professional affiliations include past president to the Sri Lanka Energy Managers Association, life member to the Sri Lanka Association for the Advancement of Science, Institute of Environmental Professionals Sri Lanka, and GHG Management Institute. Furthermore, he is a member of the National Expert Committees to National Climate Change Mitigation Expert Committee, member to the National Net Zero Roadmap Development Team, National Energy Award Evaluation Panel, and Presidential Environmental Award Evaluation Panel. And Mr. Nimal Perera is a member of the UNFCCC National Roster of Experts to the National GHG Inventory Development. But last but not the least, Mr. Nimal Perera has recognized with the Special Award, Environmental Achievement Award by United States Asia Environmental Partnership Program in 2006. So I cordially invite Mr. Nimal Perera to conduct today's Green Talk. Yes, sir, over to you.
Thank you, Sadeepa, for the kind introduction. Let me share my presentation. Hope you all can see my presentation now. Thank you very much, the Green Building Council of Sri Lanka, giving me this opportunity to share my knowledge on this very interesting subject, the green hydrogen economy in Sri Lanka, how it will support the net zero future in Sri Lanka, and give you some thoughts about it. I don't think that within this short period I will be able to give you the full spectrum of understanding about the hydrogen economy, but I will try my best to share whatever the possible information to share with you. We've said that it would be better, as I'm talking about in my topic, the green hydrogen economy. So it's worthwhile to think about, recap something about the economy. Conventionally, how we are thinking about how we think about the economy. Basically it's a a matter of consumption of goods and services, and somebody might say production, use, and manage of scarce resources what we are entertaining in this world. In the meantime, very important kind of definition given by especially how the ancestral people, our ancient people, how they define the economy, depending on or basically satisfying with the resources offered freely to the society by the nature. So they were really behaved according to the lines of the nature. And in the meantime, no extra or irreversible effect or impact is being done to the extract of for the extraction of resources, as what we are doing currently. They never drilled here. They mainly look on the sky, and they were mainly depending on the natures what they have given freely available. In the meantime, it's worthwhile to think about what is the sustainable economy. With this basic definition on sustainability, satisfying the basic and civilized needs of the present generation without compromising the same needs of the future generation. Because always we should think about what are the hopes and what are the hopes of the future generations, what they are looking for. And if we are right, if we are totally destroying this resource base, how they are going to survive? So that is one very big question mark we have in front of us. The lifestyle with minimum damage to the natural system. That's another way which we can define the sustainable economy. The meantime, again, we can define it as the satisfying the present generation needs with the limitations of Mother Earth's carrying capacity. Because Mother Earth has certain carrying capacity uh, to reverse back what we are throwing back to the environment. Let's say basically the waste what we are throwing back to the Mother Earth surface, and we are dumping on the Mother Earth surface. There is a natural capacity, but we have gone beyond that limit. So that's why we have all these problems. That's why we have to talk about something called the sustainability as well. So these are the major three. Of course, there are a number of challenges. Out of those challenges, these are the major three challenges we are facing today. Number one is the climate change, and then loss of biodiversity and the plastic pollution. According to the UN definition, these are the major challenges we are facing today because of our heavy consumption patterns. Nothing else other than the heavy consumption patterns and the heavy pollution rates what we are experiencing in the world. So out of that, the climate change, the impacts, we are very seriously, we are entertaining. I have to say that we are entertaining, right? Because we never thought about the mother earth or the natural behaviors of this earth, and then we have consumed so much of natural resources, especially the fossil fuel sources we have been continuously extracting, and all these the waste gases, especially the greenhouse gases we are emitting to the environment. And then the greenhouse gas concentration has already carbon dioxide concentration, according to the reports, it has reached to about 423 parts per million, according to the last July records. The healthiest limit was somewhere around 250. The reversible limit was somewhere around 350, but now we have reached 223 or even closer to 425. Definitely, this one will reach to 250 parts per million, but I don't know what will be the repercussions of this particular case. Uh, it's officially the July because of that increased heavy. According to the meteorological organization in the World Meteorological WMO has reported the July 23 was the warmest month ever recorded for the last maybe about nearly about 500,000 years. So it's a very pathetic situation. we are totally, out of our control. I don't know how, but this is not the time for us to think about that. But in front of us, we have one savior. That is the net zero economy. If the global communities get together and if they achieve net zero economy within a shortest period as much as possible, that would be the only solution which we can think about is getting away from this catastrophes of this severe catastrophe of this climate change. In simple terms, the net zero means the cutting greenhouse gases emissions to a close to zero, almost zero as possible, with any remaining emissions, because there are certain emissions are being already added to the atmosphere as well as to the ocean. And if we can make some kind of a mechanism to reabsorb them and we can reach to the healthiest limit, at least to the 350 parts per million level within a short period, that would be the only, kind of solution which we can think of in front of this climate change impact. The economic plan with zero or closer to zero GHG emissions. So this is what we are talking about, the net zero economy. And then planning major economic sectors towards zero, almost zero emission levels, such as what are the, according to the UNFCCC classification, these are the, or the IPCC classification, these are the major economic sectors we are mainly talking about. The energy sector, that includes transport sector, industry sector, the energy sector includes the industry energy consumption as well. But in the meantime, the industry sector, there are certain inherent the process-based emissions as well. And then land use change in the forestry related emissions, and their economic, repercussions, agriculture sector and the waste sector. So all these sectors are normally are responsible in emitting greenhouse gases, including carbon dioxide, methane, nitrous oxide, mainly. So how we can think about that? If we can go beyond the limits, if we can reduce as much as possible these gases, the emissions, and then reduce some of the already the emitted gases back to the if we can reabsorb them, so that definitely that would be the only solution. That's what we are defining as net zero economy. So if you according to the 2016 net zero challenges, so these are the major sectors, their contribution. The energy sector, nearly about 73.2% of the global emission. That includes the energy use in buildings, transport sector, energy use in industry, and all these sector together, nearly about 73.2%. We have a challenge to reduce this one. The in 2016, the total emission was somewhere around 49.4 billion tons of carbon dioxide equivalent. So you can imagine what is the challenge we are having in front of us. And then, but still we have the major contributed from energy sector, and major mainly we are contributing to this emission mainly because of the use of the fossil fuels, carbon containing fossil fuels, which have been developed maybe about millions and millions years back. Due to some natural reasons, they were being sent to the deeper layers of the earth, and we have started, for the sake of our development, for our development comfort and the development needs, we have started drilling the earth, and we are now extracting them, and the carbon contents we are now releasing back to the atmosphere. So that's the major, the problem we are facing. That's the major mechanism we are making the greenhouse gas enriching the atmosphere. But in front of us, we have a solution. Why we should depend only on the fossil fuel? As the shortest, the energy life cycle, if you think about the shortest energy life cycle, and the resources available. The right hand side of my slide, you can see the capacities of. I have made I did a kind of. I'm showing a kind of a comparison of the availability of total reserves of coal and then uranium, oil, and even natural gases. And again, I'm comparing with the solar energy, the total availability of solar energy. As an example, you can see the coal availability is nearly about 900 terawatt years. But according to this one, the solar energy, 23,000 terawatts continuously or every year, we have the capacity. Until the sun, closes, it's the operation. I don't think that it will happen immediately, but I don't know whether it will happen tomorrow or maybe another millions years or something. But according to the scientists' prediction, we will have about nearly about 40 or maybe nearly around 4 million years, the life of the sun. Anyway, we'll have a good hope on that side. And then having this optimistic, hopes, definitely, we can think about the solar energy, tidal energy, wave energy, biomass, wind, all these things. We can think about to replace our energy requirement, which we are satisfying with the fossil fuel sources. But still, we have a big challenge: the intermittency, because during the night time, no solar energy, and also even the wind energy is bit of intermittent. Even the solar energy is having kind of intermittency. So therefore, we have to have some kind of a storage mechanism to absorb these energies and then perform our development or the day-to-day activities. So if you make a kind of wind power availability. So you can see these are actual data from 1st June 2018 up to 1st September 2018. So you can see the grid absorption capacity I have shown with a red line. And you can see at a certain point, it goes above the grid absorption limit. So it means it's a kind of a waste of energy which we are supposed to uh, absorb and deposit. So that gives a kind of opportunity for us to think about or plan for some storage technology. So what are the storage technology? Green hydrogen, again one kind of but before going to the green hydrogen, I will say like pump storages, maybe battery storages, maybe lithium, sodium, or maybe even the flow batteries or whatever it is, the battery technologies for the storage. And then thermal storages, flywheels, or maybe gravity storage, different types of storages we can define, but their applications are having certain limits. But when we are talking about the energy storage technology, especially with the pump storage, battery, and other technologies, we are limiting the outcome to one particular area, that is only the power benefit. Out of that, again, we can get only the power or the electricity. And again, there may be some the environmental impacts, especially in the case of battery storages or maybe thermal storages. We have to think about the life cycle concern. And then when you think about the life cycle concern, and then there are definitely the resource impacts. For the waste resource impact or maybe resource extraction impacts, there are a lot of impacts. In the meantime, if you think about these pump storages, you may have noticed what happened during the last couple of weeks in Sri Lanka. If we go for these major hydro projects, if you are keep on continuously, pumping and storing, what would happen to the irrigation sector and the drinking sector, which drinking water sector, which has already given the priority in Sri Lanka than the energy supply. So it's again a problem. But again, if you think about the hydrogen, if we can generate hydrogen using this excess energy, which has already been uh, discarded from our system due to the over capacity, we can think about a multi-purpose. We can think this hydrogen as a kind of a multi-purpose sources, which I will tell you later. Why we are thinking about, we are so much interested about hydrogen. It's the most abundant kind of element in the atmosphere. Uh, and its cleanliness, it's a zero carbon, kind of element if we burn it even. The highest calorific value, megajoules per kilogram, in the right hand side, in this chart, you can see hydrogen is having 120 to 142. And if you compare with any other liquid fuel except the natural uranium is normally has about nearly about 500 megajoules per kilogram approximately. But all the others are having a lower value. So therefore, it's worthwhile to think about hydrogen. And then again, if you think about the hydrogen flame temperatures, you can see it has a temperature at the mixed with the air and pressure of 1 atmosphere. It gives about 2,400 temperature in Kelvin. So that's one was the reason we can use this one as a resource for welding purposes as well. And then general use of, these are some of the list of general usage of the hydrogen, like spacecraft, welding, nitrogen fertilizer industry, food industry, and then methanol production, hydrochloric acid production, reduction of metallic ores, balloon filling, which we are used to do this one in our childhood, and cryogenics related studies, as a automotive fuel in electric vehicles, either direct combustion system with a direct combustion type, or maybe hydrogen fuel cell type. In the meantime, we can use hydrogen as a source of energy storage. And keep in mind, hydrogen is not a source of energy, it's a vector of energy. It carries energy from one place to the other place, but it doesn't, we are not considering this as a source of energy because it's naturally, this is not available. But some uh, parties now they are talking about something else, the naturally available hydrogen also, but I am not addressing this one due to certain reasons. When you talk about the hydrogen economy, the hydrogen as an energy vector to strengthen the global economy. So that's the main reason. We are trying to bring the energy, mainly the energy from one place, and we are trying to transfer it to somewhere else. The hydrogen economy uses hydrogen to decarbonize the economic sector, essentially hard to abate sectors such as the power sector, transport sector, and especially industry sector. Now, if you think about the energy requirement for steel industry, cement industry, and even the glass industry, this is a very good solution, right? But again, there are limitations. There are certain aspects which we have to think about if you are considering the current available sources of hydrogen. In order to phase out the fossil fuel and limit the climate change, this is a very good key for that particular purpose. Hydrogen can be generated from different modes, which I will briefly discuss in my next slide. And so because of that, we are defining hydrogen color spectrum for the identification of different types of hydrogen sources. Uh, this is starting from black hydrogen, brown hydrogen, which is again produced out of black coal and brown coal or the lignite. Gasification, normally we produce this black and brown hydrogen. But the GHG footprint or the emission of greenhouse gases in these particular cases are very high. And other than that, we are using sometimes the natural gas like methane. uh, and then do the maybe the pyrolysis of the natural gas, and then we are producing the gray hydrogen or the Turkish hydrogen, which we are defining them as solid carbon byproduct. And but they are the carbon footprint is very high. Compared to the black and brown, less, but still they are emitting certain amount of carbon. And also their byproducts are basically solid carbon. And then blue hydrogen again related with, if we can, if you use the natural gas reformation and then carbon capture and underground storages, and the mainly we are using the feedstocks are basically natural gas and coal, but still they're having a low carbon footprint compared to the others. And then the yellow hydrogen, which we are using, the feedstocks are basically mixed of various grid energy. It may be a mixture of renewables and non-renewables. It has a medium range of the GHG footprint. But if you go for a purple or a green hydrogen, always almost the greenhouse gas footprint is minimal. In the case of purple for the hydrogen, we are using the nuclear energy to produce uh, the hydrogen. Basically, nuclear energy is used to electrolyze the water and then generate hydrogen. But in the case of hydrogen, wind, solar, or the maybe hydro, geothermal, renewable and sources. And I'm sure that you can understand you agree with me. The greenhouse gas emission of the carbon footprint is almost zero or maybe very minimal. So therefore, our main focus is going to the green hydrogen. But of course, I'm not going to discuss about the purple or the pink hydrogen, mainly because of certain non-renewable nature of the nuclear energy. And why we are thinking so much about the white green hydrogen? Because there are certain factors like increased availability of and the low cost of renewable energy. You can see in the right-hand side diagram, the graph from 2010 to 2020, sorry, 2022, the levelized cost of solar and wind, especially the solar energy, the cost has been is being coming to a very sharply to a very low level. That is one of the reasons, and also the electrolyzers. There are two main types of electrolyzers we are using in this particular case, like PEM and the AEM. PEM is basically polymer electrolyte membrane type, and the AEM is basically anion exchange, the membrane types. So their cost is also gradually going down. So that means we can keep some kind of a hope for the to produce green hydrogen with a low cost. So that's one aspect. And then the carbon abatement targets, which we can think about, because especially the hydrogen production contributes. If you go for the gray hydrogen, currently what we are doing in the world, contribution is about 830 million metric tons of carbon dioxide per year of emissions. So these are not a simple amount. So therefore, adoption of green hydrogen can avoid nearly about 60 gigatons of carbon dioxide in 2021 to 2050, the prediction given by International Energy Agency. And then advancement of technologies like advancement in handling and usage of flammable and the reactive hydrogen, and then development of hydrogen-based industrial processes, especially fuel cells, internal combustion engines, and gas turbines, etc. And then advancement in production technologies based on electrolyzer, because currently these technologies are very rapidly they are developing. And at the bottom part of my slide, you can see the carbon dioxide emission per kilogram of hydrogen. So you can see, especially the black hydrogen, gray hydrogen, and blue hydrogen, they're having certain amount of the carbon dioxide emissions. But in the case of pink or maybe Turkish or especially the green hydrogen, there are almost no or maybe almost zero carbon dioxide emissions. So that's one of the main reason why we are talking very seriously about the hydrogen economy. So some of the applications currently in the world where they are using this hydrogen. I'm sure that most of you all know the fuel cell electric vehicles working with the hydrogen. You can see because they have the fuel cell system and hydrogen storage, and basically the electrical vehicle component in the front side. And then these are some of the Mercedes-Benz models already in the market, and also they have produced the new models as well. And then these are some of the Toyota, and then Hyundai, and then BMW, Nissan like models, which they have come up with this fuel cell technology based uh, electric the vehicle. And the most advanced, again, the advanced vehicles produced by Toyota now, because they have gone beyond especially the Toyota has gone beyond the fuel cell vehicles. Now they have even gone for internal combustion engines with hydrogen. That is also one of the major, kind of a step ahead, which they have put it into the scene, especially in the economic activities. And this is basically the new thinking about Hyundai. Well, I have been had the experience of traveling with one of this bus in 2012 when I had a study visit to South Korea. They have taken us with this particular buses. So you can see, I will play a part of it.
Dream of a cleaner, healthier planet. Technology that brings man, nature, and the automobile together as one. Hyundai Motor Company, leading the way to a cleaner global environment, strives to begin a new chapter in automobile history, dreaming of the fresh, green future of mankind. Cell vehicles are automotives running on electricity produced by the electrochemical reaction between hydrogen and oxygen within the fuel cells. Also, zero-emission vehicles, their only byproducts being water. Technology of such perfect clean cars lies in fuel cells.
Okay, sorry. I will move to sorry, there is a small technical problem.
Dear all, there's a technical issue on our side. Please give us a few minutes to sort out it. Thank you.
Now you can see the presentation. Can you see the presentation now?
Yes, sir, we can see now.
Can you all see?
Yeah, yeah.
Right. Sorry about the technical issue. And then these are some of the these are some of the transport buses already developed by different people, different organizations like Tata, Hyundai, and some other organizations. And very interestingly, this is actually the train, Corelia Island train introduced by the Germany. They actually, it's basically a French technology developed by Alstom, but nearly about 18 of these machines are now in operating in Germany. This is basically, I'm not going to play the videos. You just make a kind of a web search about this Corelia Island, this one, the railway, hydrogen railway, then you will find this because there can be some issue when if I try to, play the video. And then let's try again. Let's see.
The environment is one of today's main issues with society is being concerned. Alstom has for years taken part in the environmentally responsible approach of developing comprehensive, non-polluting solutions for the sector of rail transport. Today, rail operators mostly use diesel trains to operate passenger service on non-electrified networks. Now, Alstom offers a CO2 emission-free regional train and a silent alternative Coradia Island. Powered by a hydrogen fuel cell, its only emission is steam water and condensed water, while it operates with the lowest noise levels. Alstom is one of the first manufacturers worldwide to develop a passenger train technology. Thanks to this technology, Coradia Island enables sustainable train operation while its performance matches that of regular regional trains. Coradia Island is special for its combination of different innovative elements: a clean energy conversion, a flexible energy storage capacity, and smart management of the traction power and remaining energy. The principle relies on a fuel cell, which produces the electric power. It's the core of the system. The fuel cell is supplied with hydrogen on demand. By combination of hydrogen with oxygen from ambient air inside, the fuel cell produces the electric energy needed to supply the vehicle.
But then again, this one gives another, direction. How the India is taken this challenge. The India is roll out the hydrogen-powered train on Independence Day. Actually, they have already planned. Definitely, what they said is they are going to start the hydrogen train before the end of this year. So that's their kind of the target. And in the meantime, for Sri Lanka railway sector, especially for our young engineers, this is changing area. Because the railway electrification, it was a kind of a dream for us since 1970s. But if we go for railway electrification in Sri Lanka, then either we have to go for overhead power carrier, or maybe the third rail, the shoe connected power supply. But both are not very feasible for our country. The first one is mainly because of the high cost. The second one is because of the safety reasons and the nature of our railway tracks. But of course, if we can think about the conversion of our existing locomotives to hydrogen with the existing railway lines, so that can be considered as a good, opportunity for us to think about, especially the young engineers. They can think about especially the research R&D areas, which we can plan for our Sri Lanka, at least for our railway sector to convert to the hydrogen. That will be a good option for Sri Lanka. And again, the other countries like Oman, they have already planned for build up the world's largest green hydrogen plant with the use of heavy systems. And Sri Lanka also has taken the first step towards the green hydrogen. The government already signed an agreement with the Green Stat Hydrogen India, which is a subsidiary of Norwegian energy firm called Greenstat Norway, to carry out the studies on green hydrogen in Sri Lanka. And the main purpose purpose to address the energy security issues coupled with the NDCs and the climate change commitment from our side. In the meantime, the agreement signed in February 2022, and they have gone up to the development of draft roadmap for Sri Lanka. And some of the key areas which I would like to highlight: the phase one, which is planned to be in place from 2022 to 2025. The policy regulations, demonstrations, and pilot of and offshore studies. In this case, basically, mainly they are focusing on the offshore wind resources. So that's the important feature in this particular study. And they have already developed the draft roadmap as well. And then maybe a certain and so many initiatives are being planned with that. And also by 2025 they are planning to introduce a couple of hydrogen operated buses in between Colombo and Jaffna. So these are something this was during there are some of the discussions. And during the phase two study, phase two of this particular roadmap, from 2025 to 2028 of the hydrogen production and supply chain and offshore developments. Also, they are planning with that. And then as the phase three, 2028 from 2028 to 2035, liberation and production and scaling up of green ammonia manufacturing because they are planning to go for extend the hydrogen further up to green ammonia. Green ammonia will be used in marine fleets as well as the throughput for the resource for the green urea manufacturing. And there are a lot of plans to in this particular case. They are planning certain export of green hydrogen, green ammonia. Particular exercise. They are planning for some collaboration in strong collaboration between India and Sri Lanka. Something like expand the network of green hydrogen dispensing stations is one of the part of this particular case. And then as the phase four, which will end up the this particular exercise in between these two countries, Sri Lanka and this Green Star India. 2035 to 2048, the green hydrogen market stabilization and capitalization of the export market. Again, stabilize the domestic demand, including rail transport. But in this particular case, they are especially focusing on the rail transport, the tail end of this particular case, like 2048. So my ambition is before that. If we can think about if the country is having a big courage, especially our young generation and the engineering and the science community, if we can get together, we can have a very good collaboration on this particular case, and we can think even beyond before the plans to achieve something in our country. So that's something which I want to keep in front of you. So that's why we have already have a collaboration between the Sri Lanka Energy Managers Association, my association, SLIMA, and the National Science Foundation. We have already started some joint activity, especially focusing on R&D, awareness and technology. Universities, especially the engineering and the science activities are available. We are going to connect into this particular action platform. Basically, that will be a kind of a clearing house or a kind of a place for everybody to get some kind of information on national and global the green hydrogen related information. And we are planning to publish a e-newsletter on green hydrogen. And then maybe we are planning, we have already drafted some national symposium on green hydrogen and also the regional or international symposium on green hydrogen as well with our collaboration. But of course, we are going to connect all the national universities as well. So with all these things, we can keep some kind of a hope, especially for our energy sector. Our main focus is absorbing as much as possible the renewable energy into the grid. And then in the meantime, develop certain, because we have already drafted some pilot projects, which we are thinking we have already had some discussions with some, ceramic sector and the tea sector organization to operate the kilns and the furnaces with green hydrogen and the renewable energy. It's a hybrid system. But basically, those will be captive hydrogen, not the grid connected. So therefore, a lot of plans are there. In future, we will open up all these our activities, and also we are going to connect with this Greenstat India and the team from this Greenstat India, and also the major stakeholder organization One is Sri Lanka Sustainable Energy Authority and Sri Lanka Petroleum Development Authority. Uh, these two organizations also will join with us for this our consortium, and we are going to have a good collaboration and to give out more and more information about the opportunities about the green hydrogen in Sri Lanka. Let's have a good hope for the sustainable hydrogen economy future in Sri Lanka. Sorry about this technical issue which we faced in, unfortunately. But if you have any particular questions within a short period, I would be able to answer those. Thank you very much. Sandeepa, over to you.
Thank you, sir. So if you have any questions regarding today's session, now you can unmute your mics and ask the questions.
Excuse me, I am Terence here. Mr.
Yep.
Nimal,
Yes, sir.
yes, can we use seawater to generate green hydrogen?
Yes. One
What
of
is
the
the
target will
technology
be
involved?
there are certain repercussions with the use of the seawater, because when you use more and more seawater, there will be salt concentration, the spots of salt, high salt concentration in the sea. So therefore, we may have to face this, we may have to find some solution. Initially, we are thinking about the fresh water, the clean water. But again, now the technologies have already been developed for seawater as well. But the byproducts again, like maybe chlorine or maybe salt, will be again used for the purpose of developing byproducts. So those are already in the research bench, and some of the partially commercial operations are also in the world is happening currently. But basically we can use it. We can use seawater. There is no issue. Certain changes to be made in the electrolysis system.
Then
Any other questions?
yes, then I have a question, Mr. Nimal. So when we can comparing other renewable energy sources with regard to the green hydrogen, what is the cost? What is the cheapest to use?
Again, I have to remind you, hydrogen is not an energy source. It's only a vector. It will do only the transferring of energy from one place to the other place. Now, in this particular case, it will transfer the renewable energy through hydrogen to somewhere else, through the fuel cells or maybe combustion technology. It will transfer the renewable energy from one place to the other place. So therefore, it's not considered as a source of energy. But of course, as you correctly pointed out, there are certain cost issues. Especially, that's what I have already shown in my one of my slides. That is here. You could remember the cost of the electrolysis. The cost of electrolysis and the cost of renewable energy. And also, if you go for the reverse powering, that is the fuel cell technology. Especially in the case of fuel cell technologies, the efficiencies are very low. So then you have to go for maybe tri-generation or maybe four-generation technologies to reduce to increase the efficiency, overall efficiency. So in that case, definitely the efficiency and the cost effectiveness will go up. This can be considered as a very good option for maybe in future, very soon. Some plans to introduce this one for the industrial zones. So that is one kind of a good potential place to uh, have some pilot projects even in Sri Lanka. But one thing is the cost is very rapidly going down. Now you can see in this particular case of the levelized cost of solar, how it reduces from 2010 to 2022. Now it has come to the almost comparative level with the coal power, coal-based power generation. So therefore, similarly, the electrolysis technologies also will come into that direction. There are a number of researches happening throughout the world. So therefore, there will be some good future.
Thank you, sir.
Any other clarification? Yeah, anybody, if you have any question, you can either raise verbally or maybe you can put it in the chat box.
I have one question. My name is Ruben. Is the hydration a harmful gas for living creatures? Because my concern is if I use it for internal combustion engine, it may exhaust through the throughout to the environment.
Sorry, your voice is very faint. I can't hear very clearly your question. Can you repeat it again, please?
Yeah, is hydrogen a harmful gas for living creatures, or this is not harmful? If it is released to the atmosphere, because of some accident or from the engine.
Okay, I can understand your question. One is actually, according to the research, there is no any direct harm. Even if you inhale hydrogen, there is no any impact is being recorded according to the sources. But as you correctly pointed out, it has a safety issue because especially you could remember the World War One. I was not there actually even, but I could remember the bomb used in World War One was basically hydrogen bomb. It has a very high level of the explosive value. But again, if you think about the LPG or any other gases, even some other gases, they also have the same safety issue. But that's why we have researchers and science and engineering researchers, which we have to go for safe technologies. And when we are developing them, currently a lot of safety standards are being developed on this particular, especially the ISO standards are being in the process of development. Some are already developed with related to the hydrogen safety. So it's not only the safety of the gas, and again there are special issues with the hydrogen is the hydrogen embrittlement. But when you do the storage of hydrogen, it will have a deterioration of the metallic structure, especially the steel structure. There will be a deterioration. So that calls in meteorologically that's called the deterioration or the hydrogen embrittlement of the metal surfaces. For that one also there are a number of research are being done. The safe technology is already been developed, but of course there is a safety factor. Now, even if you think about the gasoline engine or LPG gas combustion systems or the boiler, whatever it is, they have certain amount of safety risk. That's why we have safety standards. That's why we are doing R&D work. That's why we are trying to always go with the safety standard. So definitely with the safety standard, there won't be any serious issue according to my understanding. There will be safety issues, but the risk can be minimized with the technology. Hope you received the satisfying answer.
Yes, sir. Thank you.
Any more other questions? Any other questions?
Yes, Mr. Nimal Perera, I'm Mudalige.
Yeah.
So as per my understanding, now there are certain application of the green hydrogen. So what are the outcomes of those things in particular in the case of accidental issues? I mean,
There
in the matter of safety.
Yeah, according to the information, because continuously I am receiving the information related to this hydrogen technologies in the world.
Okay.
Very recently, there was one case. There was a one case reported very recently. There was explosion, but there was no any fatalness to any person. There is no any personal injuries. Only the material or the property damage was there. Other than that, maybe in the history there were some safety or the kind of explosions when they had a balloon when they sent to the atmosphere. There was a kind of explosion. They have reported sometimes back. But very recently, very few accidents. Only one or two cases have been reported. But again, as I explained earlier, we may have to go for a lot of research and safety applications. So that's why very recently I got the information from ISO, International Organization for Standardization. They have come up with a lot of safety regulations and the standards when we are going for hydrogen storage, transport, and even during the production. So if we can adhere to those kind of standards and the regulations, definitely we can minimize the accidents, but I won't say zero accidents. There can be, because even in the case of gasoline vehicles or maybe use of LPG or maybe natural gas or whatever it is, there can be even a 0.1 probability of going for accidents. But with all these safety regulations, definitely we can minimize the safety risk, and then we can think about the hydrogen economy.
Thank you.
You're welcome.
Mr. Perera, my name is Arthur, and I just wanted to have two questions. One is just a clarification of some of the things that you mentioned.
Yeah.
From my understanding, I think, you mentioned this as well, the precursor to a hydrogen economy or green hydrogen economy is a renewable heavy grid, which I think Sri Lanka's target for 100% renewable grid is 2050. So if the plan to establish a green hydrogen economy, anything before that, it won't really be feasible. Is that right? Until the grid is completely renewable, because we would have to convert the existing demand for electricity into renewables, and then also convert the additional demand for manufacturing of hydrogen into add that capacity into the grid as well, right?
Yeah, you are quite right, because the number one target, because always my target is not to promote hydrogen technology. Hydrogen should be a kind of a vector or a kind of a shock absorber for the grid excess energy from one side. But in the other side, if you forget about the grid, there are opportunities to go for captive hydrogen production. Let's say if you are kiln or a furnace owner, then you can produce your own, let's say for a kiln, if it is 100, let's say 24/7 operating kiln, you need to power the kiln continuously 24 hours. Maybe during the daytime, you can directly use the electricity directly for the, heating of the particular oven or the kiln. And the additional, the electricity generated from this renewable system, at the same site, you can generate certain amount of hydrogen, which you can use during the night time or maybe during the cloudy period. So that is basically for a captive operation. I'm not connecting this one with the grid operation. Grid operation will be a different case because then we have to think about the microgrids or maybe like maybe some smart technologies coupled with that. Because currently, about a couple of years back, I had an opportunity to visit to Germany to see their Siemens operation in how they are operating the what you call the wind system. When the wind system feeds to the grid, when they have excess electricity, immediately they start the electrolyzers, and then they capture the green hydrogen, purify it, and inject it to the natural gas grid, because they have a natural gas grid which they are supplying the natural gas to uh, the industry or to the domestic sector. And then what happened is basically with the limited injection of the hydrogen which they produce from the wind energy, increase the thermal value or the calorific value of this particular stream of natural gas. So that's how they use it. So similar cases we can think about, but unfortunately we don't have any natural gas grid. We can think about some other directions, maybe like producing, going for to produce more and more, maybe biogas, and then enriching the biogas with hydrogen for the higher thermal value. So like cases we can think about. That's something which we can. So all these things, we need some tailor-made kind of specific research activities for the country. So that's one of the reasons why we are trying to go for this consortium in between the National Science Foundation and Sri Lanka Energy Management Association, and to give a kind of a clearinghouse, what we need to do and what is happening in the country and so on. Because otherwise what would happen is, especially in the case of the research institute like universities, they will repeated the research. Maybe one university do the same thing, the other has done, others has already been done. So we don't want to repeat the whole thing. So to have a very effective kind of R&D network and information clearinghouse, one of the main target why we are thinking about why we have planned this collaboration.
Thank you. And just one follow-up question to that, Mr. Perera, was that you talked a bit about industrial heat as well. So I've worked with the Renewable Thermal Collaborative out of the US on thermal storage systems and other solutions for industrial decarbonization for heat specifically.
Right.
And what we've understood is because of the efficiency loss in conversion, essentially electricity to hydrogen back to electricity or thermal sources, and also the need to retrofit some of the gas turbines, for example, that GE has. Heat batteries using bricks and other materials might be a more efficient process for thermal heat. Do you have any thoughts on that option?
That depends again on the technology and the use of the hydrogen. Because if you are using, if you look only the power sector, power outcome from this hydrogen yes, of course, what you said may be correct. But still, the repowering through the fuel cells has a efficiency issue. But in that case, particular case, again, if you can couple with the either cogeneration or that's how even the Japan currently they're doing. According to the information I received from the Japanese this hydrogen sector, in certain places they have gone for trigeneration. What they do is from the excess electricity what they generated from the which they generate from the national grid, that particular grid portion, they use it to generate hydrogen, and then hydrogen again used through the fuel cell technology to repower the grid. But in this particular case, as there is a heavy heat wastage, they have gone for trigeneration. With that, what they have reported is basically their overall efficiency has gone up to nearly about 92% according to their the reports.
That's good. So that means they're capturing the lost heat as well and then reusing it. So that kind of offsets some of the efficiency losses, I'm sure. Great. Thank you.
And also the purpose. Let's say if you want to go for fertilizer industry, then it could be a good application, because the application is not limited only to the power. That's the beauty of hydrogen. You can think about either fertilizer industry, methanol industry, or maybe certain lot of other spectrum of usage which we can plan for this one. Not only the new power sector. So that's why I told you, I have mentioned the main first thing would be saturation of the grid with renewable energies. And for the grid balancing, the main option, number one is we have to think about either to go for battery storages. It may be like solid battery storages or maybe in flow storages or whatever it is. And then we can think about if we need to consider about the other applications like industrial applications, then this would be the ideal way. Hydrogen would be the best way.
Great. Thank you.
Yeah.
Hello, sir. Now I think we can wind up the session.
Sure.
Okay.
Yeah. Anyway, I'm very sorry about the technical issue happened because of the transition during the transition of the slides.
Okay. Thank you very much, sir, for your inspiring, conducting highly inspiring lecture and taking time from your busy schedule to be the resource person today and sharing your valuable knowledge for us. And as well as thank you for being a great audience today and give me a few minutes to inform you about our training programs and our workshops. So can you stop your share screen? Okay, thank you, sir. Green Building Council of Sri Lanka offers comprehensive courses and training programs to train industry professionals and undergraduates. So this is our associate professional training program. So if you want to become a green accredited professional, this is the first step for that. Our 45th batch program is you can now register our 45th batch. It is conducted fully online, and this is our next assessing and management of the organizational carbon footprint calculation workshop. We planned this course with comprehensive course content and real-world case studies, success stories with practical sessions. And we have to conduct this workshop on 29th and 30th September. You can register before 20th September. And this is some photographs of our last batches of this workshop. And if you want to know about our other training programs, workshop, webinars, and our green talks, you can contact us through our email, education.gbcsl@gmail.com, events.gbcsl@gmail.com, and our contact number is 9112-679-130, and you can know more things from our website. And thank you again, sir, and all. Stay tuned our upcoming events too. Thank you all, and good night.
Okay, thank you all and good night.